Given a positive integer n written in decimal form, the alternating sum of the digits of n is obtained by starting with the rightmost digit, subtracting the digit immediately to its left, adding the next digit to the left, subtracting the next digit, and so forth. For example, the alternating sum of the digits of 180,928 is 8, which is the rightmost digit here, 8 minus 2 plus 9 minus 0 plus 8 minus 1, which is 22. Justify the fact that for any non-negative integer n, if the alternating sum of the digits of n is divisible by 11, then n is divisible by 11. Now, given a non-negative integer n, we can write in decimal representation what n is. N is some d0 plus d1 times 10, which is the tens place, and the digit for the hundreds place, d2, all the way up to, so that'd be times 10 to the nth power. The alternating sum we'll define by s is going to be the digit in the ones place minus the digit in the tens place plus the digit in the hundreds place, and so on, and then plus. Now, the last term is either going to be positive or negative. Now, if n is even, then we would want a positive here. So I'll put n here so that when n is even, this will be positive. So negative 1 to the nth power times dn. Now, the next step is very tricky to justify at this point, since we haven't used modular arithmetic yet. However, the important thing to understand is that odd powers of 10, in other words, 10 to the k, is equal to negative 1 mod 11. And that's why these numbers turn into a minus here. That's precisely when k is odd. If k is even, then 10 to the k is just 1 mod 11, which means that for each of these terms, we can reduce these numbers 10 to the k to be either plus or minus 1. In this case, 10 squared is 1 since k is even. We're working with mod 11 here. So once we show that, we can show that n equals s mod 11. We just have to reduce all of these powers of 10s to either plus or minus 1, and that's how we show that n is equal to s mod 11, which means if 11 divides n, then 11 divides s, which is the alternating sum. Thanks, everyone, and I'll see you in the next video.